Hey guys, let's get working on the next lesson. Chapter 9, Lesson 4, Subtracting Like Fractions. Same thing we did yesterday. Essential question: how can I use operations to model real world fractions? Okay. Suppose a waiter earns $6 an hour and makes $15 in tips each night. Create a function table to show how much the waiter would earn if he worked 4, 5, and 6 hours. Okay. So when they talk about a table, I'm going to get you started here. He earns $6 an hour and he makes 15 in each tips each night, not an hour. Okay? So just keep that in mind when you do it. So I'll give you about a minute. Okay, let's look at it. So if he works for $6 an hour and makes $15. So he would work here because I know that 4 times 6 is 24 plus 15. So he's going to make $39 for 4 hours. So again, I'm going to do 5 times 6, which is 30, plus my 15. Boy, I hope I get this right, or Mrs. Orlovsky's going to really have a field day with this one. All right, 36 plus 15, carry my 1, 51. All right, let's check my work, you guys. Woof, I got it right. 6 times how many hours, which is here? 4 plus 15. Okay? All right. I'm going to do this real quick. I'm just going to do one of these slides because you know they'll take forever. 3/10 plus 4/10 is 7/10, and that's already in simplest form. I know that 7's a prime number, and there's no other number that can go into it other than 1 and 7. All right, 1/8 plus 3/8 is 4/8. And in simplest form, I know 4 is half of 8, so it's equal to 1/2. All right, I'm just going to quick go right through these, okay? Because you know we don't always do that. How is subtracting fractions similar to adding like fractions? When they say like, they mean that they both have the same denominator, okay? This is a like fraction because their denominators are the same. So how are they the same? How is subtracting like fractions similar to adding like fractions? Well, you just add the numerators. That's all you do. It's just do your numerators, and that's how you find your answer. Okay. subtract, record the differences in simplest form. So here they are telling me specifically that I need to do it in simplest form. So I better do it. All right, 5/6 minus 3/6 is 2/6. I know that 2 can go into 2 one time. And I know that 2 can go into 6 three times. So my answer is actually 1/3. 4/5 minus 3/5 is 2/5. That's already in simplest form because there's not a number that goes into 2 and 5. They're both prime numbers. 7/10 minus 4/10 is 3/10. There's not a number that goes into 3 and 10 evenly. Like 3 can go into 3, but 3 can't go into 10 evenly. 7/8 minus 1/8 is 6/8. But again, I'm going to divide by 2. Okay, that's my little division. You can't see that. And I'm going to get 3/4. Now I'm done. 3/4 minus 1/4 is 2/4, which you can't see me do. 2/4. And I know that 2 is half of 4, so it's equal to 1/2. Okay? Whoever's watching my YouTube video, I appreciate you. A recipe requires 7/10 cup of flour. Courtney has already put in 3/10 cup of flour in flour in a bowl. What fraction does she still need to put in? So if you were using 10th cups, which there's no such thing as 10th cups when you're cooking. But anyway, how much would she still have? So we know that it would be 7/10. 7/10 minus 3/10. My husband's about to yell at the dog, so be aware of that. It's 4/10. And in simplest form, I can divide by 2 on both sides. And I'll get 2/5, okay? 4 divided by 2 is 2. So think of it this way. 2 times 2 gives me 4, right? 5 times 2 gives me 10, okay? So when you think about that, that's how I want you to think about it. Got it? All right, here's Math in My World so you guys can pick up in your books with me. Liliana jogged 5/8 of a mile on Monday and 3/8 of a mile on Tuesday. How much farther did she jog on Monday? So we know that 5 minus 3 is 2/8. Now, they didn't ask us to put it in simplest form, but we don't usually say 2/8 of a mile. You would probably put that into simplest form. So you would divide by 2 on both sides. And you would get 1/4. Okay, so 1/4 of a mile is something we usually say. But 2/8 isn't wrong. It's still the exact same thing. It's just different numbers. They're equivalent fractions. 1/4 is equal to 2/8. Okay. One-fourth. See how they brought it all? See how they did it here? They said it's 2/8, but we know that 2/8 is exactly the same size as 1/4. Look, it's exactly the same size. It's just here I cut it into smaller pieces. Okay? This is when I'm eating my candy bar and I cut it. I have this much. Here I cut it into 2 pieces. Here I eat the whole thing. Oh. All right, now the other thing that you could do is use a number line. I don't see why you would need to do that, but I can't think of any person in our class who would not know that 7 minus 5 is 2. I can't think of anyone. So I know you guys would know 2/10. The thing is I just want you to remember you have to put that in simplest form. This book is really pushing that. So I would divide by 2 on both sides. 2 divided by 2 is 1. 10 divided by 2 is what? What is it? I don't know. It's 5. Well, it's 5. It would be 1/5. So let's go to the next slide and see. Did we get it? 2/10? Yes. Okay, see, and then it's 1/5. Starting that thing again. All right, guided practice. Find the difference and write it in simplest form. So we got to remember to do that. 6/8 minus 3/8 is going to be, it's doing it. 3/8. Is it? Okay. Hold on. 6/8 minus 3/8 is going to give you 3/8. Okay. So that's in simplest form already because there's not a number that goes into 3 and 8 except for 1. All right, what's our next one? 11/12 minus 5/12. 11/12 minus 5/12. 11 minus 5 is 6 over 12. Now I know that 6 is half of 12, so it's equal to 1/2. Or you could divide by 6. Because 1 times 6 is 6. 2 times 6 is 12, right? Okay, let's look at the answers. How would you find 7/8 minus 1/8? You would subtract your numerators and you would leave your denominators alone. All right, independent practice. So you guys can do numbers 3, 2, easy. I would say, let's see, where are we? Sorry about that. Well, I'll tell you, I'm pretty sure you're going to go up to, whoops, sorry. You're going to go up to like 18 or something. I'm not sure. I have to look at the book, but I don't have it in front of me. So you are going to go ahead and do your independent practice. Let's see, problem solving. So I would say up to number 17. Okay? All right, guys. It was great. I had a great time. Hope it was easy. All right. Bye.